Honda Technical Training presents Measuring Compression and Cylinder Leakage. Good. Everything looks like it's ready. We better get to it. We've got a good day's work ahead of us.
Okay.
What do you see here?
A car.
You passed test number 1. The obvious doesn't escape you.
Okay. It's a Honda.
Right. What else?
I don't follow.
What is it besides a Honda? Okay. Let's approach it from a different direction. Today we're going to concentrate on engine inspection and repair. How you approach this Honda can help you.
How?
This is a darn good automobile. It's also a precision machine, built to precise specifications by the factory. If you're going to inspect and repair this machine, your engine overhaul skills have to be as precise and dedicated to detail as possible. That's what sets you apart as a Honda technician from a shade tree mechanic. This engine is built to micron specs. That's exactly why we're going to emphasize precision measurements. They're critical to successfully completing the RO.
I see what you mean.
So what's the first thing we do?
Well, what's the RO say?
Very good. Well, the RO is rather vague. Customer isn't quite sure. Loss of power, fuel consumption is up.
Better start from the top.
Okay, where's that?
Well, before we begin to tear down the engine, we'd better make sure of its condition.
And we don't want to perform any work that isn't necessary. That isn't good for us or the customer.
That's right. So we start to find out the condition of the engine. That means a compression test and maybe a leakage test, too.
Excellent. I knew that shop coat looked good on you. Before you take any measurements, make sure you've gotten your pre-test sequence in order.
Pre-test sequence?
Right. First, make sure the engine is at operating temperature. Next, remove the plugs. And oh, here's a little tip. Always pull from the boot, not the wire. And oh, here's a little tip here. Keep them in proper order. It's especially helpful when checking their condition. Third, keep the throttle open for plenty of air. And fourth, make sure you have grounded the coil wire properly. A little tip on this.
Yeah?
Look at these two ends. See how similar they look? It's important to learn the difference between the two. The compression gauge uses a Schrader valve. The leakage gauge valve has a hole in it. They're different, and they can get mixed up if you don't pay attention.
Okay.
Okay. Make sure the car is in neutral or in park.
Check.
With the compression gauge set into place, crank the engine over until you get the highest reading. Then record your measurements. Measure and record for each cylinder. Make sure the battery is fully charged or your cranking speed will be affected. The compression gauge will give you a ballpark look at what's going on in the engine. At least 136 psi should be developed by a healthy engine. You know you've got a problem if your measurements vary 28 pounds lower than shop manual specs or between cylinders.
Check.
Okay, let's assume you're low. Remember to release the pressure before you disconnect.
What about the wet test?
The wet test isn't used unless the dry test indicates a need for it. Even then, it's something of a judgment call. If you feel it's required, go ahead.
Well, our compression reading is definitely low, and it might give us some good information.
Okay. When you're performing the wet test, you're trying to get a handle on low compression. The way to check is to put 1 squirt or about a tablespoon of oil into each spark plug hole. The oil flows out over the piston, helping to seal up the rings. When you do the compression check again, and the reading comes up, what have you got?
Rings.
Right. What happens if it doesn't come up?
Valves.
Sure, probably a valve problem.
What happens if you have 2 adjacent low cylinder readings?
You tell me.
It's probably leakage between the cylinders because the head gasket's blown.
Yes, good thinking. A hint here. After the test, rotate the engine with the starter motor to blow the oil out of the spark plug holes. Be sure to hold your shop rag over the holes, or you'll get oil all over everything. Okay, Let's take a second to summarize what we did on the compression check. Number 1, engine at operating temperature. Number 2, battery fully charged for proper cranking speed. Number 3, throttle open. Number 4, ground the coil wire. And number 5, crank to the highest reading. What next?
Leakage test.
Right. You found out about as much as you're going to with the compression gauge, so you need to go to the leakage test. The leakage tester allows compressed air into the cylinder through the adapter. Now, a cylinder isn't perfect. A certain amount of air is going to leak out past the rings, past the valves. Hopefully not, but it may even leak past the head gasket. Whatever. A certain amount of air is going to leak out of there. Anything under 20% leakage is pretty acceptable. Anything over that, and you've got a problem. The first thing we have to do is calibrate the tester. That's done here at the bench. Your air supply connected to the cylinder leak tester should be between 80 and 200 psi. With the adapter connected to the coupler on the leak tester, it should be 100%. Without your spark plug adapter attached, you should have zero leakage. There. If the tester isn't calibrated, you can lift the red ring, rotate the knob, and calibrate it back down to zero. After you calibrate it, make sure you double check it by performing another test. If it comes back to zero, it's calibrated correctly, so snap down the red ring. Now everything's locked into place and you're all set. You ever used one of these?
Yeah, a couple of times.
What do I do now?
Get TDC.
Right. You have to have the piston at top dead center. Very good. Now there are a couple of ways you can do that. First, if the car's in for major service and the valve cover is removed, you can use the timing marks on the camshaft pulley to get TDC. Second, there's a mark on the flywheel that tells you where TDC for number 1 is. There's even an easy way to find TDC for the proper firing order, too. To determine the proper firing order, first put number 1 on top dead center. Then remove the distributor cap. Mark the location of the rotor. The firing order on the Honda is 1, 3, 4, 2. You're on 1. For 3, turn the crank pulley 180 degrees counterclockwise. Another 180 degrees and you have TDC for number 2. Another 180 degrees and you have TDC for number 4.
Sounds pretty easy.
It is. Now I'm going to plug it in. Then the gauge will tell me what percentage air is leaking past the rings, valves, or whatever.
You ever have a crankshaft turn on you when you put the compressed air in?
Sure.
What makes that happen?
That means I didn't have it on exact TDC. What it means is that the rod was at a slight angle and the air pushed it down. That's why you've got to have it perfectly straight up in the air so it can't push it down.
Gotcha.
If the crank turns now, that means I'll have to check my TDC. Be sure to set the emergency brake.
No rotation.
I lucked out. Now I need to check my leakage.
28%.
That's quite a bit, probably excessive.
What's the cutoff point?
20%. Now you've established leakage. You need to check where the leakage is. The air could be coming from several different places. It could be coming out of the crankcase. If I listen here at the oil filler hole on the valve cover or the dipstick and I hear air escaping, where's the leakage?
The rings.
Right. The air is leaking past the rings into the crankcase. Another tip here. Use a 5/16 hose to listen for air at the dipstick hole. Trying to get your head in there might be a little painful.
Okay.
Okay. Another place to listen is at the air intake. For that, you can listen at the air cleaner inlet.
I don't hear anything.
Oh, where else might you have a problem?
The exhaust.
Right. In that case, you've got to go back to the exhaust pipe and look for air coming out there. No, sounds pretty good here. Okay. You check the crankcase, the air intake, the exhaust valve, and there might even be a leak at the head gasket. Listen at the spark plug holes, and remember to keep an eye out, or maybe that should be an ear out for air escaping from adjacent holes. You also should check the radiator to make sure you don't have any pressurized air coming through there. You want to make sure the pressure's off. You don't want to lobster your face out. A scalding's no joke. No bubbles here. Okay, let's recap what we've done. We've calibrated our leakage tester. We got TDC,
Top dead center.
and we made sure the emergency brake was set. We put compressed air in and measured how much air came out. Most cars, if they're in decent shape, you'll find something in the range of 5%. If you get over the 20% range, you've got an engine that's worn.
Gotcha.
If that's the case, you want to pinpoint what area it might be worn in. We found we had a ring problem. That figures with the RO, low on power. Okay, ready for your review questions?
I guess so.
You haven't forgotten anything.
I don't think so.
Well, how about the grommet in the inner fender? You took it out to be able to turn the crank pulley, remember?
Oh, yeah.
Not putting it back is just plain sloppy.
Okay, boss. No shade tree garbage for me.
Attaboy.